Hi, and welcome to our presentation, Using Video Analysis to Improve Pre-Service Elementary Teachers' Noticing Skills. My name is Lisa Poling, and I am a professor at Appalachian State University in Boone, North Carolina. And I have two research partners that worked on this project with me. They are Liza Mondurant from Delta State University in Mississippi and Diana Moss from the University of Nevada, Reno. So as we started thinking about what we wanted this research to look like, we first came up with our research question. In the past, we had done a lot of work with the professional noticing framework, but we wanted to figure out how we could implement the professional noticing framework in an online environment. So the research question that drove our research for this project was, in the context of a 4-week online mathematics course for pre-service elementary teachers, does the experience of analyzing videos of students discussing their mathematical thinking lead to improvements in pre-service teachers' professional noticing skills? When we thought about what we wanted the framework to support the research to look like, or where we were coming from, we first went back in and looked at research pertaining to what it means to observe, what it means to do something online. So in what we found is that when pre-service teachers are often asked to do an observation of a classroom experience, because there's not a structure or a way for them to enter into the observation, that oftentimes what they do is they tend to focus on areas such as classroom management and discipline instead of the content that we're interested in them looking at. So we really started to think about how the professional noticing framework could support them in the observation experience to make it a more rich and inviting place for them to grow as teachers. So as math teacher educators, we know that it is essential for us to support teachers in their growth, pre-service teachers in their growth. So we wanted to make sure that when we ask them to use a professional noticing framework, that we did it in a very intentional way. And again, in this research, we've used it in a virtual environment. So just to remind you what the professional noticing framework looks like, we took the framework from the Jacobs, Lamb, and Phillip work of 2010. And so what we were asking the teachers to think about is when they were watching the videos to consider how the students would attend to the work that was presented to them. So what were the things that the students were doing as they began the problem? What were the students doing to help support their thinking? Were they using representations? Were they doing certain equations? Whatever. What was the piece that they started? How did they start to engage in the problem? The second piece of the framework is interpreting. So when the pre-service teachers looked at what the students had completed, what did they decide were the items that the students understood well, struggled to understand, but making progress, or the items that they didn't understand at all and needed significant support? So, with the interpret piece, it supports then the final piece, the deciding piece. What are the next steps that we expect the teachers to do to help support the students' growth? So based on what they saw that the students did, what they understood what the students did, what is the next thing in their instructional strategies that they are going to do to provide students the support and guidance to move them forward? Again, earlier I mentioned that we had done significant work with using the professional noticing framework in face-to-face environments. So why did we decide to use videos this time? As we know, as math teacher educators, the education is changing quickly so that we have many more courses being offered online. We have, because of COVID, we had students' experiences being online in the classroom. So how could we support those students' growth in a meaningful way and still do it in a virtual environment? So we decided, with the use of videos, logistically, it makes sense because videos are available at any time. So it allowed students more flexibility in their own personal schedules. Um, the use of videos also allowed the pre-service teachers to go back and review the video multiple times. So it wasn't happening, you know, in in time, but it allowed them to go back and maybe catch things that they hadn't noticed before. So, in looking at the research that supported the use of videos, we did look at the Starr and Strickland research from 2008, and where it did show that there was a significant increase in pre-service teachers' abilities to notice through the use of video.
Next, we will talk about the instructional activity. Let's begin by discussing the context. Our study took place during a 4-week online summer session. Typical semesters of this course last 15 weeks. Therefore, the material was condensed into a 4-week summer session. Whereas we usually spend a month on each of the following topics: number theory, fractions, decimals, and integers, 1 week was spent on each topic. There were 15 elementary ed pre-service teacher participants. In addition to this activity, the participants also engaged with readings, reviewing slides, watching lectures, taking some assessments, completing homework assignments, discussions and projects, and reading a noticing article called New Lenses on Teaching, Learning to Notice. Here we see an example of the tasks that the students in the cognitive interview videos engaged with. So when I say students, I'm referring to the K-5 students in the cognitive interview videos. So we chose a topic of comparing, I should say a skill of comparing. And then for each of the units in the course, fractions, decimals, and integers, we selected a video with a task that involved comparing fractions, comparing decimals, and comparing integers. So we tried to do that so that there was some commonality about the content that the students were engaging in, and therefore the pre-service teachers were analyzing the engagement of the students in. Overall, the videos were about 5 minutes long, and they were one-on-one interviews. The students in the videos were given manipulatives as appropriate to solve the tasks. And the pre-service teachers watched and analyzed 28 videos, but in this study, we focused on the 3 videos that had to do with comparing fractions, decimals, and integers. And they used the professional noticing framework to conduct their analysis. So here we see the prompts that the pre-service teachers were given. We had 2 questions for attending. What did the student do? What strategies did the student use? For interpreting, we asked, what does this mean about the student's understanding or misconceptions of the mathematics? For deciding, we asked them to consider, based on what you attended to and interpreted, what are the best next steps with the students? And finally, we posed the question, what questions would you ask this student? Let's discuss the methodology. We used sequential exploratory design. Initially, we collected data, then we coded it using qualitative analysis. Then we analyzed the codes using quantitative analysis, and finally, we interpreted the results. To code the data, which were the pre-service teachers' analysis of the cognitive interview videos, we used the professional noticing coding scheme created by my two co-presenters and co-authors. And this coding scheme has 3 levels of noticing: peripheral, transitional, and accomplished. For peripheral, a student would make general impressions, such as the student understands the questions. For transitional, they would highlight noteworthy events, also providing general impressions, but include why they believe something occurred. For example, the student used logic to reason through the problem. The most accomplished level is where the student uses evidence to elaborate on student understanding and makes connections between the work of the student and the next steps that they would take instructionally. To code the data, we used open coding. To prevent any potential coding biases, all pre-service teachers' names were removed, and we randomized the data on the spreadsheet. We calibrated our coding by discussing inferences and interpretations, and we independently double-coded all pre-service teachers' responses for 2 of the 3 videos in a blinded format, as I previously mentioned. Our percent agreements across all items was 75%, suggesting substantial inter-rater reliability. Any disagreement was reconciled through discussion.
Next, we'll look at our initial findings from this study. So through the lens of the noticing framework, which was attending, interpreting, and deciding, the results of this study show patterns of growth related to the noticing levels of periphery, transitional, and accomplished. So once PT's responses were coded using the scheme, the results of the noticing levels were analyzed for each of the 3 noticing assignments in the given semester. So this graph shows the overall frequency of periphery, transitional, and accomplished. So 6.1c comparing fractions was done in the beginning of the semester. 7.1a comparing decimal numbers was completed in the middle of the semester, and 8.2a ordering integers was done at the end of the semester. So as we can see from looking at this graph, the periphery slightly decreased. We can see that transitional kind of was down and then up and then back down. But most notably, we can see that the accomplished level increased from the beginning of the semester to the end of the semester. Here we have the same results, but this time in a table that show the overall percentages of periphery, transitional, and accomplished. So we can see here that periphery level went from 83% to 69% from beginning to end of the semester, where accomplished went from just 1.5% to 10.7%. So there was an increase there in the accomplished, which we saw in the previous graph. So let's take a look at each of these a little more in detail. So this is attending by activity. So you can see with attending, there's hardly any change at all from the 3 assignments. So you can see that it's just slightly different with the yellows, reds, and blues. But you can see the majority are in the blues, which is periphery, throughout the whole semester. And a very small amount are in accomplished and transitional. So there wasn't much change in the attending by the activity. Next, let's look at interpreting. So in the interpreting by activity, you can see that in the beginning of the semester, which was the comparing fractions unit, there were no students in the accomplished level at all. But as we moved through the semesters, we did get some students who were coded as accomplished. You can also see that there was an increase in transitional from the beginning of the semester to the end of the semester. And periphery, we can see decrease from the beginning of the semester to the end of the semester. The last category is deciding. And deciding is where we saw the most notable increase from in accomplished. So you can see that in the beginning of the semester, most students were in periphery, some were in transitional. In the middle, we ended up with a small amount in accomplished and more in transitional. And then you can see that it's almost like the part that was in accomplished and transitional in the middle of the semester split to more in accomplished and the other half in transitional. So you can kind of see that split there in the deciding. So let's look at what we think this means. Remember that this is based on our initial findings. This was just an initial part of the data collection that we are presenting here today. So conclusions based on our preliminary findings. The first one is that some PT's skills did not show an overall increase, and few PTs reached the accomplished level. The next one is prior to this course, PTs had little experience describing students' work, interpreting students' understanding, and deciding on the next best step. And that was very clear. PT's initial interpretations seemed to rely on their own content understanding related to the task. And this limited the PTs in interpreting student understanding of the task and deciding on the next best steps for teaching. Next, we have that the use of video to support PT's understanding of student thinking may be a viable strategy to include in a math methods course. And through a deliberate scaffolding of an instructional sequence, MTs can help PTs develop their noticing skills. So, although our data is very preliminary, we do see that there are some benefits to using video to improve PT's noticing skills. And it also helped us as MTEs reflect on how we are teaching the course and what types of activities we are providing to the students. The other thing to keep in mind here is that each chapter that we talked about, beginning, middle, and end, was a different type of content. So it is possible that some students understood fractions better than they understood comparing decimals, or maybe it was the opposite way around. Maybe ordering integers was more simple for them than comparing fractions. So we also need to keep this in mind next time we do a similar project where maybe we want to keep the content the same through the semester. And lastly, a few more implications for future research. More research is needed to determine how to scaffold PT's noticing skills development. So we were trying to create an instructional sequence to help PT's noticing skills. And we need to do more research to best determine how the scaffolding occurs. Like, how do we get them from this periphery to the accomplished level? What do we need to do as MTEs to help our students develop these skills? We also found that there's a need for MTEs, math teacher educators, to spend more time reflecting on and discussing implications for teaching. So in the very beginning of the course, we saw that on the first noticing assignment that most students were not in the accomplished level when they were discussing the next best steps for teaching. And maybe that is showing us as MTEs that we need to spend a little more time viewing videos and diagnosing student understanding with our pre-service teachers so that they know what to do next. Because a lot of time teaching is spent working with students, figuring out what content they know, what they understand, and moving on to the next best steps. Like, how can I help this student better understand the mathematics? And also, more research is needed on how MTEs engaging in this work can reflect on our PT's reasoning and improve our practice and students' professional noticing skills. So we would actually like to discuss during our presentation at PME-NA this year, what are some things that we are all doing in this line of work? How are we reflecting on our PT's reasoning, and how can we improve our practice and students' professional noticing skills? I think it's a difficult skill to teach, especially with pre-service teachers who have either rarely or never been in a classroom with students. So we'd really like to expand on that discussion during our presentation. Thank you so much for watching this video, and we hope to see you at our presentation.